This lesson is on encoding binary numbers. My name is Sonia Van Hook. When I look inside the computer, I see storage, some wires, a central processing unit, a fan, and other pieces. And if I want to communicate with this computer, I have to speak its language. The computers today speak binary. Binary is a notation that utilizes only two options for each selection, either on or off. A bit is one digit's location, which is short for binary digit. In this example, it would be a 0 or a 1. A byte is 8 bits. Notice how we spell byte, B-Y-T-E. Encode is transformation from one representation to another. Decode is the opposite. Convert a coded message into something familiar. Binary language is a base of 2. If I wanted to represent the number 13 in binary language, I would use this grid. Notice it starts at 128 and goes down to 1. Think of it as 128 little dots. If I wanted 13, 128 would be way too many. I would need to come all the way down to the grid to the number 8. We would need 1 8, 1 4, 0 2, and 1 1. Where do these numbers come from? Remember, it's a base of 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. To represent 13 in binary language, it would be 0, 0, 0, 0, 1, 1, 0, 1, or 8 plus 4 plus 0 plus 1 equals 13. Let's get some practice encoding some numbers. We'll go to scratch.mit.edu and we're going to play the binary game. This is what the game looks like, and across the top you'll see the same numbers that we saw before in our grid. The number that we're going to encode in binary will be in this brown box right here, and the number that we have will be right here in purple. And whatever number shows here, we're going to see if we need 128 dots, and if we don't, we'll go down to the 64. Do we need that number? If we don't, we will go down to this one until we have selected all of the squares that we need to encode the number. Easy enough, except they put a timer right here. The timer puts a little pressure on us. We have to get the number encoded before the timer goes off and we get a pop-up that says game over. I'm going to click on start and let's get our first number. 240. There we got it. So I'm going to click on the go, and that stops the timer, and that allows me to go to round 2. Let's get our second number. 56. All right, we have it. But let's let the timer run out and let's see what happens if we don't get it encoded before the timer runs out. And there it is. It says game over, and it will start back over at round number 1. Even though we had completed several rounds, it would start back over. When you get the game over, if you want to keep trying, you click on the green flag up in the top, and it will start over. And there we go. All right, take some numbers on your own and play the game to encode some numbers into binary. Happy coding!